Yes, variable frequency drives, or VFDs, can indeed be used on small residential compressor motors, including those found in air conditioning systems. Utilizing a VFD on a residential air conditioner offers several advantages, notably energy savings, reduced noise and vibration, extended motor life, and potential savings on standby generator sizing. Firstly, energy savings are achieved because VFD allow for the adjustment of the motor's speed based on the actual load demand. This means the compressor operates only at the speed necessary to maintain the desired temperature, optimizing energy consumption and preventing unnecessary power usage. Secondly, VFD contribute to a reduction in noise and vibration originating from the air conditioning unit. By precisely controlling the acceleration and deceleration of the compressor motor, the VFD minimizes abrupt changes in speed, leading to smoother operation and less mechanical noise. Thirdly, extended motor life can be expected when using a VFD. The reduced stress on the motor, resulting from controlled starts and stops and optimized operating speeds, helps to prolong the overall lifespan of the compressor motor. Fourthly, the use of a VFD on an air conditioner can potentially mitigate the need to upsize a standby generator. VFDs significantly diminish the starting current typically drawn by the air conditioner, enabling a smaller generator to adequately handle the load without being overwhelmed by the initial surge. Selecting the right VFD for a residential air conditioning motor requires careful consideration of several factors. It's crucial to ensure compatibility and optimal performance. Firstly, voltage rating is paramount. The VFD must be rated for the voltage of the specific air conditioner motor to prevent damage or malfunction. Typically, residential air conditioners operate on either 120 volts or 240 volts single phase. The VFD chosen must match this voltage. Secondly, current rating is another critical specification. The VFD needs to be capable of handling the rated current of the motor. The motor's nameplate provides the full load amps, or FLA, which indicates the continuous current the motor draws under normal operating conditions. The VFD current rating must equal or exceed this value. Thirdly, frequency range is also important. Selecting a VFD with a frequency range compatible with the operating frequency of the air conditioner motor is essential. In most residential applications, the standard operating frequency is 60 Hz, so the VFD should support this frequency. Fourthly, protection features are non-negotiable. The VFD must incorporate protection features such as overcurrent, overvoltage, and undervoltage protection to safeguard the motor and the VFD itself from potential electrical faults. Overcurrent protection prevents damage from excessive current draw, overvoltage protection protects against voltage spikes, and undervoltage protection prevents damage from voltage dips. When installing a VFD, consulting with a qualified electrician is highly recommended. A professional electrician possesses the knowledge and expertise to properly install and configure the VFD. They can ensure the VFD is set up correctly, that it is not causing any issues with the air conditioning system, and that all safety protocols are followed. The electrician can also perform the necessary wiring, grounding, and testing to guarantee the system's safe and reliable operation. Some additional considerations when using a VFD with an air conditioning compressor motor includes harmonic distortion. VFD can generate harmonic distortion on the power line, which can potentially affect other electronic devices in the home. To mitigate this, consider using a VFD with built-in harmonic filtering or installing an external harmonic filter. Motor compatibility is another aspect. Not all motors are suitable for use with VFD. Older motors, in particular, may not be designed to handle the rapid switching frequencies produced by VFD. In such cases, it may be necessary to use an inverter duty motor specifically designed for VFD operation. Furthermore, proper wiring and grounding are crucial for safe and effective VFD operation. Follow all applicable electrical codes and manufacturer's instructions when wiring the VFD. Ensure that the VFD and motor are properly grounded to prevent electrical shock hazards and minimize electromagnetic interference. Also, parameter settings must be configured correctly. VFD have numerous adjustable parameters that must be configured correctly for optimal performance. These parameters include motor voltage, current, speed, acceleration, and deceleration rates. Consult the VFD manual and seek guidance from a qualified electrician to ensure these parameters are properly set. Lastly, regular maintenance is essential for prolonging the life of the VFD and ensuring its continued reliable operation. This includes periodically inspecting the VFD for signs of damage, cleaning the VFD to remove dust and debris, and checking the VFD cooling fan to ensure it is functioning properly. The benefits of using VFD with residential air conditioning systems include improved energy efficiency, reduced noise and vibration, extended motor life, and potential savings on standby generator costs. However, it's essential to carefully select the right VFD, ensure proper installation and configuration, and perform regular maintenance to reap these benefits and ensure safe and reliable operation. Regarding specific codes and standards that may apply to VFD installations, firstly, the National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including those involving VFD. It covers aspects such as wiring methods, overcurrent protection, grounding, and safety requirements. Secondly, underwriters' laboratories, all standards are relevant for VFD safety and performance. UL listing indicates that the VFD has been tested and meets established safety standards. Thirdly, the American National Standards Institute, or ANSI, develops standards for various electrical and electronic equipment, including VFD. ANSI standards may address performance testing and safety requirements. When selecting a VFD, ensure that it complies with relevant UL and ANSI standards. Also, local building codes may have specific requirements for VFD installations. Check with your local building department to ensure compliance with all applicable codes. In regards to harmonic distortion, VFD can generate harmonics, which are unwanted frequencies that can distort the voltage and current waveforms on the power line. These harmonics can potentially interfere with the operation of other electronic devices and cause problems such as overheating of transformers and conductors. To mitigate harmonic distortion, firstly, use a VFD with built-in harmonic filtering. Some VFD have built-in filters that reduce the amount of harmonic distortion they produce. Secondly, install an external harmonic filter. External filters can be installed on the power line to further reduce harmonic distortion. Thirdly, use line reactors. Line reactors are inductors that can be installed on the input or output of the VFD to reduce harmonic distortion. Fourthly, follow good wiring practices. Proper wiring and grounding can help to minimize harmonic distortion. Regarding motor compatibility, not all motors are suitable for use with VFD. Standard AC induction motors can often be used with VFD, but some motors may not be able to handle the rapid switching frequencies produced by VFD. These rapid switching frequencies can cause insulation breakdown and premature motor failure. To ensure motor compatibility, firstly, use an inverted duty motor. Inverted duty motors are specifically designed for use with VFD and are built to withstand the rapid switching frequencies. Secondly, check the motor's nameplate. The motor's nameplate may indicate whether it is suitable for VFD operation. Thirdly, consult with a motor manufacturer. If you are unsure whether a particular motor is suitable for VFD operation, consult with a motor manufacturer. Regarding wiring and grounding, proper wiring and grounding are essential for safe and effective VFD operation. Follow all applicable electrical codes and manufacturer's instructions when wiring the VFD. Also, ensure that the VFD and motor are properly grounded to prevent electrical shock hazards and minimize electromagnetic interference. When wiring a VFD, firstly, use the correct wire size. The wire size must be large enough to carry the rated current of the VFD. Secondly, use shielded cable. Shielded cable can help to reduce electromagnetic interference. Thirdly, separate power and control wiring. Keep power wiring separate from control wiring to prevent interference. Fourthly, follow proper grounding procedures. Ground the VFD and motor according to the manufacturer's instructions and applicable electrical codes. Regarding parameter settings, VFD have numerous adjustable parameters that must be configured correctly for optimal performance. These parameters include motor voltage, current, speed, acceleration, and deceleration rates. Consult the VFD manual and seek guidance from a qualified electrician to ensure these parameters are properly set. Some important parameters to configure include motor voltage, which should match the motor's rated voltage. Also, motor current should be set to the motor's rated current. Motor speed has a minimum and maximum setting based on the application. Also, acceleration and deceleration rates should be set to prevent excessive stress on the motor and driven equipment. Regarding maintenance, regular maintenance is essential for prolonging the life of the VFD and ensuring its continued reliable operation. This includes periodically inspecting the VFD for signs of damage, cleaning the VFD to remove dust and debris, and checking the VFD cooling fan to ensure it is functioning properly. During maintenance, firstly inspect the VFD for signs of damage, such as cracked components or loose connections. Secondly, clean the VFD to remove dust and debris. Use a vacuum cleaner or compressed air to remove dust from the VFD components. Thirdly, check the VFD cooling fan to ensure it is functioning properly. Replace the fan if it is not working. Fourthly, tighten all electrical connections. Loose connections can cause overheating and electrical problems. VFD can provide numerous benefits when used with residential air conditioning systems. These benefits include improved energy efficiency, reduced noise and vibration, extended motor life, and potential savings on standby generator costs. However, it's essential to carefully select the right VFD, ensure proper installation and configuration, and perform regular maintenance to reap these benefits and ensure safe and reliable operation. Keep in mind that VFD are sophisticated devices that require careful attention to detail. By following the recommendations outlined, you can ensure that your VFD system operates safely and effectively. Regarding potential issues and troubleshooting, firstly, motor overheating can occur if the VFD is not properly configured or if the motor is overloaded. Check the motor's temperature and reduce the load or adjust the VFD parameters if necessary. Secondly, VFD tripping can be caused by various factors such as overcurrent, overvoltage, or undervoltage. Consult the VFD manual to identify the cause of the trip and take corrective action. Thirdly, harmonic distortion can cause problems with other electronic devices. Install a harmonic filter to reduce harmonic distortion. Fourthly, electromagnetic interference can interfere with the operation of other electronic devices. Use shielded cable and follow proper grounding procedures to minimize electromagnetic interference. If you encounter any issues with your VFD system, consult with a qualified electrician or VFD technician for assistance. Remember safety first. Always disconnect power to the VFD before performing any maintenance or troubleshooting. VFD contain high voltage components that can be dangerous. Also, follow all applicable safety procedures and wear appropriate personal protective equipment, or PPE, when working with VFD. Regarding the economic considerations of using a VFD for a residential air conditioner, firstly, consider the initial cost of the VFD. VFD can range in cost from a few $100s to several $1,000s, depending on the size and features. Secondly, consider the energy savings. VFD can reduce energy consumption by up to 50%, which can result in significant cost savings over time. Thirdly, consider the extended motor life. VFD can extend the lifespan of the compressor motor, which can save you money on replacement costs. Fourthly, consider the potential savings on standby generator cost. VFD can reduce the starting current drawn by the air conditioner, which may allow you to use a smaller, less expensive generator. Perform a cost-benefit analysis to determine whether using a VFD is economically justifiable for your particular situation. In some cases, the energy savings and other benefits may outweigh the initial cost of the VFD. The environmental considerations of using VFD for residential air conditioning are significant. VFD can reduce energy consumption, which can help to reduce greenhouse gas emissions and conserve natural resources. By reducing the energy required to operate air conditioners, VFD contribute to a smaller carbon footprint and a more sustainable environment. The reduction in noise pollution is another environmental benefit. VFD can reduce noise and vibration from air conditioners, which can improve the quality of life for residents and neighbors. Furthermore, the extended motor life reduces waste. By extending the lifespan of compressor motors, VFD reduces the need for frequent replacements, which conserves resources and reduces waste. Also, the reduced generator size can contribute to saving resources. If a VFD allows you to use a smaller standby generator, this can save resources and reduce pollution associated with generator manufacturing and operation. When considering using a VFD for a residential air conditioner, it's essential to weigh the environmental benefits against the potential environmental impacts of manufacturing and disposing of the VFD. However, in most cases, the environmental benefits of using a VFD outweigh the potential environmental impacts. The installation process for a VFD is critical to its performance and longevity. Firstly, ensure that you have the correct VFD for your application. As mentioned earlier, voltage and current ratings must match. Secondly, mount the VFD in a suitable location. The VFD should be mounted in a clean, dry, and well-ventilated area. Avoid mounting the VFD in direct sunlight or in areas where it is exposed to excessive heat or moisture. Thirdly, wire the VFD according to the manufacturer's instructions and applicable electrical codes. Use the correct wire size and follow proper grounding procedures. Fourthly, connect the motor to the VFD. Ensure that the motor is properly connected to the VFD and that all connections are tight. Fifthly, configure the VFD parameters. Consult the VFD manual and seek guidance from a qualified electrician to ensure that the VFD parameters are properly set. Sixthly, test the VFD system. After installation, test the VFD system to ensure that it is operating properly. Check the motor's speed, voltage, and current to ensure that they are within acceptable limits. It's also important to consider the long-term operation of a VFD system. Firstly, monitor the VFD performance. Regularly monitor the VFD performance to identify any potential problems. Check the motor's speed, voltage, and current to ensure that they are within acceptable limits. Secondly, perform regular maintenance. Perform regular maintenance on the VFD to ensure that it is operating properly. Clean the VFD to remove dust and debris and check the VFD cooling fan to ensure that it is functioning properly. Thirdly, keep records of maintenance and repairs. Keep records of all maintenance and repairs performed on the VFD system. This will help you to track the VFD performance over time and identify any potential problems. Fourthly, seek professional assistance when needed. If you encounter any problems with the VFD system, seek assistance from a qualified electrician or VFD technician. In conclusion, VFD can be a valuable addition to residential air conditioning systems, offering numerous benefits such as energy savings, reduced noise and vibration, extended motor life, and potential savings on standby generator costs. However, it's essential to carefully select the right VFD, ensure proper installation and configuration, and perform regular maintenance to reap these benefits and ensure safe and reliable operation. Remember that VFD are sophisticated devices that require careful attention to detail. By following the recommendations outlined, you can ensure that your VFD system operates safely and effectively and provides long-term benefits for your home and the environment.